Hello, everyone, and welcome to day 3 of the GopherCon Lightning Talks. Now, look, I said on Wednesday that we had an incredible slate of talks, and I provided. I said on Thursday we have an incredible slate of talks, and you know what? I delivered. Guess what I have today for you? An incredible slate of talks. It's remarkable how every time I get to present the lightning talks. It's just full of amazing people and amazing new talks. As I always say, this is an honor and a privilege for me to get to bring on fresh new voices and fresh new ideas to the community because that is how we all grow as a community. And to me, the lightning talks are one of the most important things we have as a community. It allows these new speakers to get a foothold in the door and get their voices heard. So, here's what we're going to do today. I would like to go over the rules of the game here before I bring up our first contestant. As always, each speaker has exactly 7 minutes to give their talk and to convince you that their point of view on their subject is the right point of view. FYI, my point of view, always the right point of view. Just kidding. Um, these people are talking about stuff I have no idea about. I'm really excited. So here is, they have 7 minutes. At 1 minute mark, if they will hear this sound. Perfect. And should they hit the 7 minute mark, unfortunately, they will be yanked off stage with these curtains. There we go. Boy, my finger's huge when I do that, isn't it? Everybody at home on a big screen TV is like, whoa, cut your fingernails. Oh, actually, I just did, so they're not saying that. Anyway, with that said, enough about my cuticles. Let's bring up our very first speaker. Andrew, are you there?
Yeah, I'm here. Thanks very much.
It's nice to see you. Where are you coming in from?
I'm normally in Edinburgh in the UK, but today I'm coming
Mhm.
from downtown Los Angeles.
Oh, so right next door.
Right, just about, yeah. I was excited to come join you in person, but it didn't work out. So maybe next year.
Maybe nice to say you brought the rain to Los Angeles then.
I think that was my fault. Sorry.
That was your fault. Well, anyway, take it away, Andrew. Love to hear from
Thank you so much. It's definitely very exciting to be here and presenting today. My name is Andrew. I've been coding Go for nearly 4 years now, I think, and Fine has been my focus that whole time. So today I wanted to show you how we can use the Fine toolkit to get up and running with an app and deliver it to the store in just 7 minutes, although now that's 6.5. So just wish me a little bit of luck. For anybody who hasn't heard of it, Fine is a graphical user interface toolkit for building platform agnostic applications. So applications that are written with Go and Fine will build and run on just about any graphical platform. I'll talk about the specifics a little bit further down. Um, and so these are going to work the same on every platform that you run them on, although they will adapt resolution and match light and dark mode to the current theme and so forth. So it feels about right for the person running the application. And the Fine project aims to be the easiest way to get up and running in cross-platform application development. It tries to be really easy to learn, and also it encourages your code also to be maintainable so other people can pick it up really easily. So first of all, I wanted to run a really quick setup. Now, I know most people will be familiar with this already, but right from the beginning, we want to create our project. Here I'm calling it my project. And we'll go into that directory and run go mod init for my project. So now we're up and running with our Go project. We want to add Fine as a dependency. So we run go get fine.io/fine/v2. That brings the latest version, which is part of the v2 group of versions, into your application. And really, that's all of the setup necessary. It does use some C behind those scenes. So if you haven't previously set that up, you might find that there's a dependency or two that you need to grab. There's more details on our website, but I won't go into the specifics just now. If you would like to test that your system is working with Fine, or if you'd like to explore what's available, you can run the fine.io/fine/v2/cmd/fine_demo there, which will make sure that everything's working correctly. The window will appear and it will show you all of the things that a Fine application can do. So we're up and running. I think next we need our hello world. So here is a basic Fine application, probably the simplest one. And for anybody who's familiar with Go application, it should look pretty straightforward. We have our main package. We're going to import the app and widget sub-packages from Fine, and we'll see how they're used. Inside the main function, first of all, we're creating a new application using app.new. Now that's going to do all of the system discovery, wiring up dependencies, and making sure that everything's going to run. And from that application, we create a new window. We've titled it Hello. On some systems, this title will appear above your application. On others, like mobile devices, you may never see it, but it's good to give it a name. Then we give it some content. In this situation, we're just creating a new label from the standard widget package with Hello Fine as the content. And then we pass that into set content, so it's the main element of the window. And we tell the window to show and run, which is basically showing the window and then running the application. It's just a little shortcut. So when we run this code, you'll see this window in front of you, assuming that your current system is running in a dark theme. Probably no surprises there. Hello Fine prints to the window. That wasn't really the most exciting thing. So today I wanted to cover something a bit more. Let's make a markdown editor. In fact, the code isn't that much more complicated than our Hello World. You'll see that we've included the container sub-package as well. Let's see how that updates things. So our window this time is titled Markdown Editor. And the widgets that we're creating are a multi-line entry widget, which we're calling Edit. This is where we will edit our Markdown code. And we're also creating a rich text preview widget. We're using new rich text from Markdown. Of course, the Markdown here is empty because we're starting from no content, but you could pass it any Markdown document in there. The key part of the logic of this application is that we're telling the entry that when it's changed, it should pass the data through to the parse Markdown function of our preview widget. And that's really it. Next, we're setting the content of our window, and we're using an adaptive grid from the container package. And what this is doing is putting two items side by side, but when we rotate into a vertical context on a mobile app, for example, the grid will adapt to the size available. And we'll see that. And we pass it the edit for the left or top and the preview for running next to it. And so we run that code, and you can see here we have a Markdown editor running on our desktop. We've got the content on the left that's currently being edited and a live preview on the right. That's pretty good. Now we want to package it because a Go binary isn't really a full desktop application. We use the helpful Fine tool here, which you can get installed with that command there. And using Fine package, we build a graphical application, which can also be installed using Fine install onto the current computer. We could also build for other systems, like using the Windows OS as a parameter, or in fact, we could build for mobile devices like our Android platform, where we need to give just a little bit more metadata. In fact, you could build for lots of different platforms. If you don't want to manage the toolchain, there's a Fine cross binary that can help you with all of that. And here's a list of all of the platforms that we're currently supporting. Asterisk is a little bit of a work in progress, but it's all in our main repository. You can see here the different applications that have been packaged. We've got on the bottom left, Android. We could double click the app on our Android, Mac, or we could run the Windows. And this is it running in the iOS simulator or in landscape mode, as you can see there, if you've rotated your device. And to release, we're going to then use a similar command, passing in the credentials from the operating system that Apple might have issued us, or perhaps that we've obtained from. And so I can't go into the details of all of the platform specifics, but you can see there that that's how the helper command will get you through. Once these have been built, you basically just take that and do it like you would a normal native app. So we can drag the iOS IPA onto Apple's Transporter app, or we can upload it into the website for Google Play or the Microsoft Store. And really, that's it. We've taken our first application all the way through to the App Store. There's so much more. I wish I could talk about data binding, file handling, standard dialogues, animations, and so forth, but there's just not time today. If you would like to know more, please join the Fine channels on Slack or Discord. And if you would like to know even more, or you'd like support for your business or your project, do give us a shout at Fine Labs, and we would love to help you out with your applications. I really enjoy the rest of the day. It's been great to join you today.
Thank you, Andrew. I have to say that that was a really fine presentation. Sorry, I mugged for the camera, and I don't know why. That was a terrible joke. Let's bring up our next speaker who hopefully have better things to say than me. Amit, are you there?
Yes, I am.
Welcome, welcome. Where are you calling us from?
I am calling you from Sydney, Australia.
Australia. Wow, we have time zones all over the place today. This is amazing. Excellent. Well, you're going to talk about Hugo and Go in Bed, right?
Yeah. Yeah.
Exciting stuff. Go for it.
All right. Thank you, Mark. All right. Hello, everyone. My name is Amit. So today I'm going to talk about how I converted a static website into a Go executable using the Go embed package. So I want to start off with the problem statement. And I also want to start off with that there was no problem to solve. I wanted to host, the wanted is the keyword, to host my new static website in the cloud on a virtual machine. I did not want to do, the usual way that I have been doing, and most of you probably have been doing, using, things like GitHub Pages, S3. There are various solutions that we can use, but I wanted it to do it differently, and hence my problem. So I started thinking about the solution. So my initial plan was, okay, I'll just generate the HTML, the CSS files, I'll copy it to the server, put in probably Nginx, and be done. But then I was thinking, okay, I have been working on Go recently a lot. Why not I try to write my server in Go and serve the files from the file system? So that was a second thought. And then, the lightning, excuse the pun, struck me. And then I thought of the embed package, which slowly and gradually, when it was introduced in Go 1.16, has probably become one of my favorite standard library packages. And so this was what I thought will be the solution to the problem that I created for myself, essentially. So I'll write up my content in Markdown. I'll use Hugo, generate the HTML, CSS, and then I'll write my server, with everything embedded, and then deploy or copy the binary to the virtual machine in the cloud. So this was how my first pass looked like. So I created the new Hugo site. I wrote my content. I generated the HTML and put in a nice theme. Got the HTML and the CSS files, and then I went into, so Hugo by default generates the content into a directory called public. So I go into my, change my directory into public. I initialize a Go module, and then I start coding up my server. So this is the first key aspect of this solution is writing the correct Go embed directives. So here you can see that I have got 3 lines of Go embed directives. I wanted it to be this way so that it's just, one line is not like too long. Of course, I could have put it in 1 line. The key is, of course, the site data variable, which is of type embed.fs, which is essentially, in simple terms, it's creating a file system based on the files that you have given it. And the reason for doing it this way is so that we can then essentially create a handler for this file system that we have created using the http.fileserver and http.fs functions from the net HTTP package. And the rest of it is how you'd usually just normally create a HTTP server. We create a new mux. We then call the listen and serve function, passing in the mux, and that was it. And then I built it. So I built my server using the Go build. Now, and then I SCP my server, which is the binary, to my host. One thing that tripped me off the first time I tried it was I just did exactly what I've written here. But then I realized I'm going to deploy this on a Linux system. But hey, we know that Go makes it very easy. So use the Go OS and the Go Arc environment variables. So I was hosting it on Linux on an ARM64 machine. So I just did the Go build and then copied over the binary once more. And I copied it to this location, which I'm calling local bin practical Go website. Now, the naming will become clear in a bit. And so this is a Linux Red Hat flavored distribution that I'm running. So I create a systemd file because I want this program to be running in the background, and it's a long-lived process, essentially. So this is my systemd file. which is init process on Linux systems, and init manager, sorry, and I'm running it as a user nobody so that it has the least privileges possible. And I'm also setting up the listen address to be 8080. So my server is going to be listening on port 8080. I then create a DNS record and pointed it to the public IP address of my virtual machine. So we have the DNS hooked up with the virtual machine. Now, by default, the DNS HTTPS, I want HTTPS, so that means I need something to be listening on port 443, as well as I need a TLS certificate. Now, remember, my website or my server is listening on 8080. Okay, so what do? I bring in Caddy. So I installed Caddy via the repository that the project provided, which meant it was automatically a systemd service. I created this very simple Caddy file, the practical gobook.net. So that's the DNS record. And then the key part, which is the reverse proxy. So all I'm telling it to do is any request coming into this virtual machine or to Caddy on practicalgobook.net hostname, just reverse proxy back to localhost 8080, which is where I started my Go server with all the embedded data in it. And super easy. I started Caddy, and the right that the certificate was obtained successfully. Okay, and the result is, and this is the big reveal, my new book is coming out sometime this month, and that's called Practical Go, and that's the website I created for it. So that is a problem I created for myself. I do encourage you to check it out. I think a lot of you will find this book useful. Now, okay, going back to the topic of this presentation. So, and then when I do a curl, I can see that the server is Caddy. So it's served by, Caddy, it's confirmed. It's also HTTP2 and it's HTTPS. So awesome. Now, I wanted to improve things. So I did a second pass, and that was a lightning talk driven development. So I created an automated way to create this initial server.go and go.mod. I put it on GitHub. It's the simplest of program you can think of using Go templates. And what I can now do is, instead of having to create the go.mod and server.go manually.
Excellent. Thank you, Joshua. And I agree, the Go Embed package. Thank God. As somebody who has maintained a couple of those embed packages, is definitely, I'm definitely very, very happy with that. So with that said, let's bring up our next speaker. Joshua, are you there?
Yes. Hello.
How you doing?
Yeah, pretty good.
Good. Where are you
Early in the
joining us
morning here.
from?
Melbourne, Australia. So I'm
Okay,
Aussie.
so we got another Australia. Wow, these time zones, we are all over the place today. And you're going to be talking about gRPC, which is something I know nothing about. My business partner loves it. I bow to his knowledge, so I'm very excited to hear another person's take on it. So please take it away.
Yeah, so I'm going to be talking about how to automatically generate a CLI for your gRPC APIs. This was a project that I started and I've been doing it in my spare time, and it seems to be really cool. The links and the task that we're going to be doing is we're going to be integrating with the billing CTL proto in Google APIs. So this is just for people who have used protos before, we have a service definition, we have some methods, and we've got some types. And so all the information that we need to interact with this API is right here. And to begin with, we want to just quickly use this. This is just getting some authentication tokens from the gCloud API, because that's what we're going to be integrating with. And the tool, billing CTL, is an example using the library that I wrote. So we can go Cloud Catalog, list services. We can see it's all got autocomplete. We can go page size 20, for example. We can add an authorization header in there. So we can go authorization bearer and then auth. And there we go. So we've just called a gRPC API. And so now I'm going to go through how that happened. The basic problem, which my library is trying to solve, is when you start getting a lot of teams with proto gRPC APIs, you start having like a whole repo that looks like this. You have a lot of proto files, or maybe they're across different repositories, but you need people to be able to call it easily. The first solution that comes up is using gRP curl. The problem with using gRP curl, for those people that don't know, it's just like curl, and you can call a gRPC API. You can specify the address, but you need to know all this information. So you need to have a piece of documentation side by side, or run some commands on the side. And you can add your authorization headers and then all of your information. So it's difficult to write because you need to know what you're actually integrating with, or what you're calling, and it's a lot to remember. So a better solution to this is using a CLI library like Cobra. And how this would work in an organization is that every team would have their own commands that they're responsible for managing. So this makes it easier to interact because you can have things like autocomplete and stuff, but it also means that it's difficult to maintain and every team might have different implementations for their APIs. And so this is where gRPC-TL comes in. What it does is it takes the file descriptors that you see in the generated code. And if we look at this is a piece of generated code that the Google gRPC code generator generates. And it generates this proto reflect.file descriptor file. And what this library does is it takes all the information within that to generate a CLI tool that you can use on your service. And so that's this these string of bytes here, and it has all the information that you need. So if we see a service descriptor, these are things that are sort of contained within a file descriptor. A service descriptor that describes what the service is. A method, and that gets generated to the first level command within the generated CLI. And the method descriptor, which in our proto file looks like this. So get billing account, for example, and that gets generated to the second level. And then the message descriptor gets generated to the flags. So if we can see there, I said page size 20. That has yeah, so that's all generated, and it's really easy to integrate with our CLI tool now. And then what you get is a CLI tool that was really easy to write. We can see that it was only a couple of lines of code. It's customizable, and it can automatically pick up extra information from the proto file. And one of the things that you might be wondering is, like, how does this know where to send the actual request? On the Google APIs, there's this annotation, which is Google API default hosts, and that is set to cloudbilling.googleapis.com. And so if we actually go to billing CTL and go help, the package has actually picked up that piece of information and put it into the defaulted the address string to cloudbilling.googleapis.com. So you don't need to specify like where any of that config would be. Yeah. And as a bonus, there is also a gRPC reflection. So if your gRPC service has reflection enabled, you can dynamically sort of call it. So gRPC-TL, I can go address equals localhost 8081, plain text equals true. Click tab. When I press tab, it does the server reflection call, gets all of the proto file descriptors like I was talking about before, but it gets that directly from the API, from the service, and then generates all of the things that we need to be able to call it. and you cannot know you can only know the address, and it'll be really easy for you to integrate as compared to something like proto gRP curl. And so, yeah, that's the link. There's a Gopher Slack, no one's used it. And if you want to see these slides, that's the link there. Cool, thanks.
Well, thank you very much, Joshua. It was a great talk. I really, gRPC, one of my biggest problems with gRPC is kind of exactly what you just said. Everybody's got different implementations. So it's great to see people trying to corral that beast a little bit. Excellent work. So with that said, let's bring up our next speaker. Liam, you there?
Hello, yes, I am here.
Hey, and where are you calling us from?
I'm currently in London, so in the UK.
Fantastic, nice. Fingers crossed, I'm going to be there next week.
Good luck.
If my flights don't get canceled again.
Yes.
They've already been canceled once. So you're going to be talking to us about Go and the Edge, like IoT stuff, right?
Yes, I am.
Oh, fantastic. I love IoT stuff. I know nothing about it, but I love it. Go for it. Let's hear what you got to say.
Okay, hello everybody. It's so great to be here. My name is Liam Hampton, and I'm a cloud advocate at Microsoft. A really quick agenda. So what is TinyGo? Why is it used? What have I made with it personally? And what am I doing next? So let's start with saying, what is TinyGo? It's a Go compiler for small places, as quite rightly stated on the README on the GitHub and tinygo.org. So what does that really mean? It's a subset of libraries from the standard library in the core language package, and it's based on the LLVM compiler infrastructure, which is a collection of modular and reusable compiler and toolchain technologies. Now, hopefully my slide can illustrate this quite well. It is essentially cherry picks a number of really useful libraries from the main language, which you have to have installed prior to having it on your machine, such as IO, bytes, archive, zip. And then it disregards things which are not necessarily seen as important, like HTML templates or the net package. And this is purely because some of the 32-bit boards that you'll be using it on you probably won't be using it for that. So let's have a look at the CLI. It looks very, very similar to the Go CLI, very similar commands. So you have build, run, test, just with a few added extras like flash when you want to flash your board, GDB, and so on. It's pretty similar, same from same. What is it used for? Well, people often use it for microcontrollers, and there's about 60 of them. It supports more than 60 microcontrollers, Arduinos, BBC Microbit, Adafruit Playgrounds, and the X9 Pro smartwatch is some of the ones which I've seen used the most. They're really popular boards, and this is just a really fun way to get into IoT if you're a hobbyist like myself. It's also used with WebAssembly. Now, if you're not sure what WebAssembly is, then it is essentially lets you write your code. So in this instance, TinyGo, and pass it through a WASM compiler, which turns it into machine readable code. And then when you go to run the application through the web browser, it runs it, because most web browsers support this. And from that, you get near native performance of your web app, which is fantastic. So where do I personally use TinyGo? I use it on Arduinos. Now, a little sidetrack here. I bought a bunch of Arduinos thinking, cool, I'm going to run some home automation. And boy, was I stuck when it came to coding them, because I didn't know C++ or MicroPython or anything like that. I don't use it in my day-to-day development. I use Golang. So I thought, light bulb moment, let's try and put Golang on a microcontroller, see what I can do. So to prevent my lovely houseplants looking like this, which looks a bit scary, it's dying. In fact, that one's actually dead now. I created something like this. I created a soil moisture sensor. And it takes some calculations. So it takes an input from the plant itself, takes it to the Arduino, does some cool calculations, and then spits out some human readable output for me. That just essentially tells me I need to water my plant when it's getting thirsty. And it helps my plant look like this, which is over my shoulder. It's growing quite nicely behind me. Secondly, another really cool project I've made is a night light. This is taking a photo resistor, and when there's no light, then obviously the lights come on, and when there is light, then the LED lights are off. for those that you want to see the boards, it's just a breadboard, an Arduino with a couple of resistors, a few wires and LEDs. Nothing exciting, but it's the principle behind what you stick in your garden at night with those solar panels on top. The syntax looks really cool. It's exactly the same as Go. So you've got your byte arrays, you've got your slices, you've got ranges. It's all the same syntax. It's really, really fun to get into if you know Go. So what next? What am I going to be creating next with TinyGo? So for my soil moisture sensor, I'm going to be creating something which will let it water itself. So I've asked Santa Claus for a water pump this year. So I'll be able to implement this one and hopefully get that one going. For my nightlight, I am going to be implementing this in a letterbox, and that may seem a bit crazy. However, for context, I live in a block of flats, and in the block of flats, it's a real arduous task to have to keep running downstairs to check the post every day. So to prevent me from running down those stairs every single time I want to check the post, I'm going to be putting something that looks like that in my letterbox. And that will just tell me that when Postman Pat has been and delivered his lovely post, then I will be able to get a notification. And through that, hopefully using MQTT IoT Hub in Azure, I will be able to do just that. And there's a lovely little GIF for you there. Secondly, there is a TinyGo playground. So much like Go, you can just go online and it's an online emulator. This will let you play with it, sort of choose your hardware, your specifications, write a little bit of code, give it a go, and off you go. I've actually written some pretty complex tasks on here where I have played with multiple boards, creating multiple little loops and lovely LED light shows just for a bit of fun. Like I said, I'm an IoT hobbyist. I don't want to make the same mistakes I did previously where I buy a load of boards, don't know how to code them and stick them on there. So I thought I'd better give this a go. But yeah, I'm an IT hobbyist, and thank you very much for listening to my lightning talk. If you'd like to get in contact, if you'd like to talk to me about this, in fact, if you're going to give this one a go, please do let me know. And you can contact me on Twitter, GitHub, or contact us and watch some meetups through the Microsoft Reactor for my work. And that is a short, sweet lightning talk.
It certainly was. Thank you, Liam.
You're welcome. Thank you very much.
Much appreciated. It was excellent. TinyGo, I still got to play with it. One of the things I miss about GopherCon, not being in person, is Ron Evans and all of his hardware shenanigans, where normally he would have a bunch of people in a room, everybody hands-on playing with stuff, TinyGo. And every year, of course, he tries to kill me with a drone. We all know that. But what you probably don't know is he often tries to get me arrested through TSA. He will routinely give me, and this is the truth, a brown bag full of just wires and capacitors and electronics and just random stuff to take on my plane ride home, just a lunch bag. And I don't know what any of it is. And if I get stopped with a bunch of wires and stuff, I can't explain what they do. And when they say, well, where did you get it? I have to say, well, here's a picture of Ron Evans. This guy gave me these things to take on the plane. So you'd probably never see Mark again. So with that said, let's bring up our fifth speaker here today. Gabriel, are you with us?
How are you doing, Mike? Good?
I'm doing great. How are you doing?
Good too, thanks.
Fantastic. Where are you joining us from?
So I am Brazilian, but today I'm speaking to you from Istanbul, Turkey.
Wow. Awesome. I love Istanbul. I was there, actually, when I first got into Go, I got to spend a weekend in Istanbul with Blake Mizurani and Andrew Guerin, who was on the Go team at the time.
Yeah.
And that turned me to Go. So
Awesome.
have a great time. I'm really excited about learning how to write some good unit tests. Go for it.
Thank you so much. So hello, everyone. I am Gabriel Bussulo. I'm working for Mercado Livre Brazil. And today I want to speak a bit with you guys about mocking in Go. I started to work on Mercado Livre and working with Go by consequence 6 months ago. And before it, I was working with Java. And when I did this transition, I started to see how things works on Golang and how people are making effort to do things simple. So I didn't saw too much frameworks around it, people doing everything more pure stuff. So even I knew it how to do some things in Java, but it was always surrounded by frameworks. And I started to struggle to do simple things like mocking on Golang. And reading some articles, reading some videos, always missing that enlightenment about the thing. And today I'm trying to bring these things for you guys here. So here I have I have built this API doing some course about Golang and testing, and this API basically is connecting to an API that we have. Sorry for this. We have on our company. It's an API that we're throwing the country and throwing some information about the country. So basically just have one URL, and we have a controller. This controller receives the ID. Going through the service, we have a provider, get the BR here, and you throw to our API. Good. So what is the problem here? The problem is that if I want to write, when I running my test here, let's run here, test. I have a test that I want to actually test a behavior that is breaking it. So country not found. But when I'm running my test, because on Go is too easy to just throw functions everywhere, and basically like on Java we are obligated to put classes and always filling with so much things and chunking frameworks, and here we can just throw functions and make things work. So here when I'm doing my test, it's working. And the problem is that it's going straight to the API and returning, let's see here, the result, it's returning a 200 on my test that I want, not found. So mocking, it's coming for solve this problem for us. So what we can do here to solve this problem? Because of time, I didn't rewrite code with you guys. I already have here on my master. I will go check out here. So one of the things that we can do to solve this problem is that, like, if we check, let me back for my other branch. As I said before, it's easy to just throw functions and get the results that we want. So before it, I was going straight to a function, and how can I mock this behavior? And other thing that is different on Golang, it's how to we are dealing with interfaces here. We can do composing with interfaces. It's so easy. You just throw interface here and you implement down it. It's a bit different for me, who was working with Java before. So here I just wrote the function, and the function is calling another function. So for mocking, one of the strategies that we can have is that, let me do check out here, is start work with interfaces. And on my service now, I have an interface that now I have the behavior that I'm expecting from the country, from this service, and making this function now associated to the struct. So now I can implement this interface. And because I have this interface here on my controller, now I'm able to create another struct implementing the same interface. And this is interesting on Golang. Like, we can, it's not a bad practice. You implement some stuff like this. So here I implemented an interface. I'll call it mock, and I'm returning a function that I declared here, the type of the function. And when I'm going through my test, now I can, because of this function that I declared here, and I'm using on the function that I'm associate with my mock, I can say the return that I'm expecting. So because of this, now if I run my code, yeah, it starts to pass, because now I can give the behavior that now I can mock my function. So the thing here is not presenting anything new, but for me it was kind of enlightening, like I'm been working with chunk frameworks and they are doing all by yourself, and you keep as something sometimes not thinking how to do simple things like this, just creating an interface, and I can mock the behavior because now I accomplished the contract of the interface, so I can associate it here a function which will return the behavior that I want. And now when I'm using the server here through the country, yeah, it's working fine. It's giving the result that I'm expecting, that I'm putting here. So now I'm not connecting with but here I'm mocking a simple function, and we need to mock a HTTPR request. So I would like to give a tip for you guys. I'm learning a lot from this repository here, learning Go with test, and this part of mocking is awesome, enlightening a lot. It's written from, if I'm not wrong, Chris James, and this article is an excellent article, how to create mock HTTP mocking in Golang. It's from Sophie, and this code that I present to you guys, it will be on my GitHub here. Is not yet, I will give push. And if you want to keep in touch, my LinkedIn is here. Thank you so much, guys.
Well, thank you, Gabriel. That was excellent. Yeah, using interfaces and mocks in testing is, you just have to. It's definitely the best way to go about doing it, especially when you start getting into some of the really, really complicated types of things when we talk about HTTP and talking with files and all sorts of stuff. So it was an excellent talk. Thank you, Gabriel, and hopefully others will get that aha moment too. So with that said, talking about aha moments, let's bring up our next speaker, Tom, who's going to talk to us about data science program at Northwestern. Is that right, Tom?
That is right.
Fantastic. And are you in some sort of ionic chamber there? What do you got going on behind you?
I am in a vocal booth.
Okay.
Soundproof, because I live in Glendale, California, as it turns out. But the apartment building has many dog owners.
Oh,
in the middle
yes.
of giving a lecture, and the dogs start barking. So this is where I come to do the Zoom sessions.
Fantastic. I love it. I love it. Well, great. I'm very excited to hear what Northwestern's doing with Go. So please take it away.
Thank you. Years ago, when I was a student at Minnesota, that's the home of the Golden Gophers, I learned a lesson about programming in academia. At the start of a course in robust statistics, the professor said, "I don't care what language you use for assignments, as long as you do your own work." I had a facility with Fortran, this is a few years ago, but was teaching myself Pascal, trying to adopt a structured programming approach. Taking the professor at his word, I programmed the first assignment in Pascal, while my classmates used Fortran. The first assignment comes due, I walk my paper, a program listing, to the front of the class and hand it to the professor. He looks at it quizzically and asks, "What's this?" I explain, "It's Pascal. You told us we could program in any language we like, as long as we do our own work." To which the professor says, "Pascal? I don't read Pascal. I only read Fortran." Lesson learned. Academics are not especially open to new programming languages. Data science students today at most universities would have a similar experience if they handed in assignments in Go or Rust or any number of other contemporary languages rather than Python. With machine learning, applications, and AI, Python rules the day. But watch out. Data oceans are choppy. Sharks are approaching. Recall the words of Chief Brody DeQuint in the movie Jaws. you're going to need a bigger boat. I would suggest that that bigger, faster boat be built with Go. Now, much what I say in the next minute or so is not new to Gophers. Remember that excellent presentation by Carmen Ando in 2017, The Why of Go. Go is machine efficient. It beats languages that are interpreted, as well as languages that depend on virtual machines. Go offers a rich set of tools for concurrent processing. It is well suited to today's multi-core computers. Go is programmer efficient. Python may be touted as easy to learn, but I would argue that Go is easier than Python. Go is simplicity by design, a language with only 25 keywords. It's easy to read, easy to use, and easy to maintain over time. Think of software development as a game of Jenga. We want to address the blocks at the bottom of the stack while ensuring that the entire stack does not collapse. Go lets us do this. And I'm happy that the leaders in the Go community are reluctant to add new features. Donald Knuth had the right idea when he got to version 3.17 of Tech. He declared that there would be no new versions, no new features, only bug fixes. And with each bug fix, he would borrow another digit from pi. Changing slowly and carefully promotes programmer efficiency. Keep it simple. Keep it running. And what about that software stack, the infrastructure? When Python, even bolstered by C or C++, is not up to the task, data scientists turn to other languages and systems. Here is a popular so-called solution to Python's performance problems. Data scientists turn to Spark, which is built on Scala, which depends on the Java virtual machine, and to provide easy access, these well-meaning data scientists add PySpark to the mix. Is this the best way to address Python's performance problems? No. Consider a simpler stack. It's Go. Just Go. On the first day of this conference, Daniel Whitenack demonstrated various ways of implementing data science solutions with Go. We can do this today. Companies value safety, simplicity, and the performance of Go. They recognize its strengths. If Go is good enough for Google, Netflix, Uber, Dropbox, PayPal, American Express, Capital One, Salesforce, Zillow, and many others, then Go is good enough for the rest of us. If Go can provide an effective platform for Docker, Kubernetes, Prometheus, Pachyderm, Grafana, CrowdStrike, dgraph, CockroachDB, Aerospike, and a diverse array of distributed solutions and cloud-native microservices, then Go can be an effective platform for building data science applications. Using Go for data science doesn't mean we have to forget good things the R and Python languages provide. We can be multilingual. At Northwestern, we're doing just that. We're using Go along with R and Python. Here's how the three languages for data science rank today, according to IEEE. Python, R, and Go are in the top 8. Go is the newest of these languages, trending up and with strong job opportunities. Take note, Gophers. Go plus data science plus data engineering is a winning combination. These are languages, courses that we're using. Go, where we're using Go as a primary language at Northwestern. And today, If you go to a Northwestern professor, you may hear these words. I don't care if you use Go, Python, or R, as long as you do your own work. Organizations need data science, and data science needs Go. We've been doing distance education for more than a decade. Most of our faculty consult with industry or work in industry. They're practicing data scientists. We offer 5 specializations: analytics management, analytics and modeling, data engineering, artificial intelligence, and technology entrepreneurship. Most students hold full-time jobs in industry and study part-time. If you're interested in data science or data engineering, love to learn new things, and want to work with Go, Northwestern is the place to be.
Well, thank you, Tom. That was excellent. If I wasn't already doing a master's program, I might consider it. Thank you so much. It's really great to see Go getting into universities because I kind of agree with Tom. I think Go is a great first language. I think it's better than Python as a first language because you don't have to deal with the white spacing and the dynamicism. And then again, I might be a little biased. I really like Go, as I'm sure you all do too. I think Go is an excellent first language. So, with that said, we have time for one more talk. So let's bring up our next speaker. Mahesh, you there? You're muted currently.
Sorry. Hey, Mark. I'm here.
Hey, how you doing?
I'm doing excellent, Mark. Thank
Great.
you.
Where are you joining us from?
I'm from Mumbai, India.
Okay, fantastic. Very, very exciting. We are all over the map in this session here. I love it. We've got people all around the world. And you're going to talk about using Go in the embedded world, correct?
Yes.
Oh,
I'm going to
fantastic.
talk about Go in embedded world. Can you see my screen, Mark?
Absolutely. Yes, you're all set. Take it away.
Thank you. Hello, everyone. I'm going to talk about an interesting topic, Go in embedded world. And I think there are so many presenters already have talked about a lot about how you can use Go in different embedded devices and products. So I'm not going to discuss something very specific to any product. What I'm going to discuss is just a single problem statement. Can we use Go as a single technology for both cloud and device side development? So this particular question came up when I was in a startup a few years back, and we were trying to find a very lean tech stack for both our devices and cloud side. So we were pondering on different languages, and we choose Go over there. Let's talk about it. I'm sure that there will be so many other teams and companies who are also having the same dilemma, whether they can have a single tech stack, which they can use in both dev devices and the cloud side. Now, first of all, is Go a solution? If it is, then why? So as Tom has already told a lot of things about Go, right? I'm not going to tell you why Go is really, awesome language for the cloud side. Multi-core support, easy for multi-threading, faster development, the test framework, inbuilt test framework, error handling, garbage collections, so many stuffs, right? That helps Go make sense for the cloud side development. Now the question is on the embedded side, on the device side, right? First of all, this is a statically linked compiled binaries. The points that I made here is very, crucial for any embedded developer whenever it is finding which language he should use and how that can be helpful. So first of all, statically linked compiled binaries, you don't have to worry about the dependencies, easy to build, and it is only dependent on the kernel, right? The third point is the empty interface equal to void pointer. I put this point, after a lot of thought. So any embedded, developer who is working with C, if you ask him, void pointer is something which he always or mostly use for transferring data from point A to point B, right? It's like really gold for him. Now, what Go provides is an empty interface, which is you can use a void pointer. Not only that, but you can use empty interface or concept of interface to design, provide a pattern to your code so that you can, use or change or support any new changes as quick as possible. How good is that, right? Now, next, two keywords, Go OS and Go Arc. Okay. Now, when I was working with C a couple of years back, the main problem, well, that's one of my demerits is I was not so good at makefile and CMake files. Whenever I have to change the platform or wherever I add some new dependencies, I always get stuck there and need a lot of help. The Go provides a beautiful way of creating libraries, creating your executables based on these two keywords, Go OS and Go R. Just tell which operating system and which architecture you want to build, and it will build that binary for you as long as it's supported. Right? And if we are talking about Go in embedded world, and if we are not talking about TinyGo, it doesn't make sense, right? TinyGo library really makes your life much easier as an embedded developer. Now, as Liam already told us about how easy to use TinyGo and how easy to use this library to create a particular product as quick as possible. Now, on top of that, the thing, I think Liam told us that there are 60 plus microcontroller available in TinyGo. I looked at TinyGo today, it was 70 plus, 71 or microcontroller. So the amount at which the acceleration is happening, the amount of microcontrollers supported in TinyGo is really huge. Not only this, there are so many other libraries are now present, Embed Go, Embedded to at Go. There are so many libraries are present, which makes any embedded developer life much easier. But enough of it positive. Let's talk about what is not there in Go. So if you're talking about embedded systems, talking about microcontrollers, you have to think about the advantage that Go brings is that is a garbage collection and how this is a disadvantage for a microcontroller. You may have to tune it down because you don't want your microcontroller to use this garbage collection feature and use its CPU cycle for that. This is something that we need to take care of in the Go. Still, there are some platforms which are not supported. So if you're working on a device which is not supported in Go, then you have to wait or you have to switch to C. Right? Now, the third point I added it here to make sure that there are so many critics of Go which says that Go is having a lot of issues with the feature list that they have, and it might not be good suitable for the embedded systems. Absolutely right. Even as per Rob Pike in GopherCon 2014, Go was actually not designed originally for the embedded usage. But look at the timeline after that, the amount of evolution that Go has brought us. It is completely awesome, and amount of support, the device side development support that Go has right now, as compared to any other language except C, it's going in a much higher speed. Just to give you how Go looks like as a code as compared to C, this is the same code. This is the same logic that you will need to toggle your LED in a Arduino board with Go. The left side is the Go and the right side is the C. Just to tell you how easy to write, how easy to develop the code in Go these days as compared to C. Of course, the people who are in already C, you will definitely have to pull yourself and look into the benefit of Go. But yes, there is an easy way to develop and learn and do. That's Go provides. So Go makes sense. Now, conclusion. Now, before the conclusion is very, can key here. What we need to do is we need to understand that Go helps to get things done as quick as possible, right? It's easy to develop and easier to, the timeline is very quick. But we have to also remember, which, Tom mentioned it properly, that Go is extremely simple and minimalistic. They don't add features as they should be, and which adds quick learning and helpful in reducing cognitive friction in any developer that you want to build it, right? With the rate at which Go is evolving, it can be a good and maybe only replacement option for C in coming future in embedded world. That's about me, and I think we made a right choice on choosing Go as both cloud and dev side in our project. Hopefully it will be helpful for you. Thank you.
Well, thank you very much, Mahesh. That was wonderful. We've come to the end of yet another set of GopherCon Lightning Talks, and for me, it's just been a wonderful week. We've seen almost 24 new speakers present some great new concepts, some new ideas, and definitely gave me a lot to think about, and I hope you as well. I hope you've enjoyed all the programming at GopherCon this week, but in particular, I obviously hope you've enjoyed the Lightning Talks, and I really hope to see you all in person next year. Well, my Gopher buddy and I hope to see you in person next year at the real GopherCon, and maybe I get to shake your hand and introduce you in person at the Lightning Talks. With that said, we still have a little bit more programming left at GopherCon, so enjoy it, and I'll see you next year. Thanks a lot. Back to the studio.